purpose of the consumer loop is to dequeue and process messages along with their message data. The consumer loop first dequeues the next queue element. It then uses a cluster properties node to extract the message, which it passes to a case structure. The case structure then executes the case that matches the message. The case structure also has access to the message data. The cases of the case structure contain the code necessary to process all the messages. After the case structure is done processing the message, the consumer loop goes to the next iteration and reads and processes the next message in the queue. This is a VI that uses the producer-consumer events design pattern to implement message communication. This producer loop can enqueue a normal priority message with numeric message data using the enqueue element node. The producer loop can also enqueue a high priority message with numeric message data using the enqueue element at opposite end node. The consumer loop dequeues the messages with their message data using the dequeue element node. Notice that the processing code has a duration of 1 second, so if the messages are enqueued faster than once per second, a backlog of messages will be created. The consumer loop dequeues messages from the backlog in the same order that the messages were enqueued, unless a high priority message is introduced. High priority messages are dequeued as soon as they are received because they were enqueued at the opposite end of the queue. Now I'll run the VI. Notice that I can create a backlog of messages by enqueuing many messages quickly. Notice that they are dequeued in the same order that they were enqueued, first in, first out. Notice that the UI controls are staying responsive even though the VI is in the middle of processing data, because the producer loop is able to focus on monitoring the UI for events. Notice that if I send a high priority message, it is sent to the opposite end of the queue, which means it will immediately get dequeued next. In summary, the producer loop continuously keeps the UI responsive. The consumer loop executes the code corresponding to the UI events in parallel. And these two loops implement message communication using a queue. In this section, we will discuss the queued message handler design pattern, which is an improvement over the producer-consumer events design pattern and solve some of its problems. LabVIEW NXG includes a template for the queued message handler design pattern. Open this template by going to the Projects tab, New tab, and then click Queued Message Handler. The queued message handler design pattern is similar to the producer-consumer events design pattern. Both use queues to transfer messages. Both have a producer or event handling loop that enqueues message and message data when an event occurs. Both have a consumer or message handling loop that dequeues and processes the message and message data. However, the queued message handler or QMH design pattern has many added benefits over the producer-consumer events design pattern. 1. The QMH provides a message queue API with enhanced functionality over the regular queue nodes. For example, the message queue API conveniently provides built-in message and message data inputs and outputs. Also, each message can have a different message data type because the message data is a variant data type. 2. The QMH provides better error handling. The QMH handles shutting down both loops if an error occurs in either loop. The QMH also allows you to configure specific errors to ignore in each loop. To further explore the queued message handler design pattern, I highly recommend that you complete the next exercise, which walks you through examining the queue. You've completed this module. Here is a summary of what you've learned.